You're standing at the edge of a small pond in a park on a quiet weekend afternoon. A family walks past you, tearing off pieces of bread, tossing them onto the water. The ducks race toward it, jostling each other, quacking. The kids laugh. The parents smile along with them. Nobody in this scene is doing anything wrong, at least not by anything they can see. It's a small act of kindness, repeated thousands of times a day, in thousands of parks all over the world. But there's something happening right now, underneath the down of the ducklings paddling in that crowd, that nobody standing on the shore can see. And almost every single duckling that develops it won't make it through the winter. Here's the part that should unsettle you. That harmless-looking loaf of bread isn't a random accident. It's an invoice. A growth invoice, written in the first few weeks of a duckling's life, and it gets paid off with its own wings. Picture a duckling's body as a construction site running on exactly one fixed schedule. Bone, muscle, tendon, feather. All of it is supposed to grow in sync, like different crews building the same tower on a timeline set by millions of years of evolution. Pour extra material into just one of those crews, and that crew starts sprinting ahead of the others. The whole structure starts to warp. Ducks, geese, swans, their ancestors spent tens of millions of years evolving to eat something completely different from bread. Pond algae, aquatic insects, wild grass seed, food that's high in fiber and minerals but low in raw energy. Their bodies were built for a slow, steady growth curve because in the wild, no season ever hands a young bird a dense, easily digestible, unlimited pile of starch. That biological blueprint was never written to handle a human standing at the water's edge, tossing down hundreds of grams of carbohydrate a day, week after week, month after month, without the bird ever having a say in it. So here's the question this video is built around. Why does an act of human kindness, something that looks exactly like nurturing, end up permanently disabling tens of thousands of young ducks and geese every single year, stripping them of flight for the rest of their lives, over nothing more than a few weeks of the wrong food at the wrong moment? There's a common belief that bread counts as a natural food for ducks, partly because they eat it so eagerly, and partly because feeding bread to ducks has been a harmless-seeming ritual for so long that nobody questions it. But bread offers almost nothing a growing duckling actually needs. Barely any protein, almost no vitamin E. None of the manganese required for bone and feather to develop the right structure. What bread does offer in excess is fast-absorbing starch. To a human, that's just a low-nutrition snack. To a duckling somewhere between 3 and 6 weeks old, it's a dose of energy that outpaces everything its skeleton was ever designed to keep up with. Here's where the domino chain actually starts falling. Once carbohydrate intake blows past what the body actually needs, the duckling redirects most of that surplus energy into feather growth, because feathers are the fastest growing tissue in a young bird's body. The feathers on the wing start lengthening and getting heavier at a pace that outruns the wrist joint of the wing, the carpal joint, meaning the joint that bends in the middle of the wing when a bird folds it against its body, can physically support. At this stage, that joint is still soft cartilage, not yet fully hardened into bone, and it's being asked to carry an ever-growing weight of feather while it still isn't stiff enough to hold that weight straight. Here's the next link in the chain. At the exact same time feathers are growing too fast, the levels of vitamin D, vitamin E, and manganese in the bird's blood are dropping, because a starch-heavy diet is crowding out the room those micronutrients would otherwise take up. Those are the exact nutrients needed for mineralization, the process where soft cartilage hardens into solid bone. Take those away right when the wing joint needs to stiffen fastest to support a rapidly growing load of feather, and you get a soft joint slowly getting dragged outward under the weight of the very feathers it's supposed to be holding in place. And here's the final domino in that chain. Once the wing joint has been pulled out of alignment, it hardens permanently in that twisted position by the time the bird reaches adulthood. The wing can no longer fold flat against the body. Instead, it juts out sideways, giving the bird a strange, almost feathery halo of a look, which is exactly why the condition earned the name angel wing. But that pretty nickname hides a brutal fact. That bird has lost the ability to fly permanently. Over a few weeks of eating the wrong thing at the one stage in, its body couldn't forgive that mistake. You can get a sense of just how widespread this actually is from one very specific case. In October of 2022, at St. Vital Park in Winnipeg, Canada, residents spotted 2 adult mallards showing clear signs of angel wing. Wildlife Haven, a wildlife rehabilitation center based nearby in Ile-des-Chênes, reported that they were fielding around 10 calls a day about birds showing the same symptoms at that single park, right during the season when locals feed ducks most heavily. That's not a rare, isolated case, and it wasn't treated as one by the people who study this. That's a pattern that repeats itself anywhere people gather to feed birds regularly, year after year, almost like clockwork, and the scale runs well beyond one park. Cape Wildlife Center, a rehabilitation facility in Barnstable, Massachusetts, treats roughly 2,000 animals a year, and a significant share of that caseload is geese, swans, and ducks with angel wing, with admissions peaking in late fall, right when the chicks hatched earlier that summer, have grown enough for the deformity to become visible. Once a wing has hardened into that twisted position, there's essentially no way to fix it in an adult bird. Wildlife officials in Indiana note that almost every bird that develops this condition eventually dies. Not from the wing itself, but from everything the wing takes away with it. No way to fly from a predator, no way to migrate ahead of the cold, no way to reach a new food source once the old one runs dry for the winter. But there's something worth being honest about here before this video goes any further. The link between bread and angel wing, even though it's backed by near total agreement across decades of field observation from wildlife rehabilitators, still hasn't been nailed down by a large controlled laboratory study. Very little formal research has actually been done directly on the mechanism itself. Some experts also point out that genetics might play a role, since even within the same flock, raised on the exact same diet, not every bird develops the condition. In other words, bread is almost certainly the trigger, but it might not be the entire explanation for why one duckling ends up affected and the one paddling right next to it doesn't. That uncertainty doesn't change the overall picture. It just sharpens it. The real problem here was never bread itself, as if it were some kind of poison sitting on a shelf. The real problem is that humans introduced a steady, unlimited surplus of energy into an ecosystem built for scarcity. And they did it right at the exact developmental window of a species, with no built-in mechanism for knowing when to stop. A duckling can't consciously decide to grow slower just because there's suddenly too much food around. It simply grows as fast as the available energy allows, and its skeleton is forced to race to keep pace, whether or not it actually can. That's exactly why kindness, in this case, doesn't contradict the outcome. It causes it. Not because anyone feeding the ducks means any harm, but because the instinct to nurture, to give, happens to land precisely on the weakest point in the biological blueprint of the very animal it's trying to help. The affection is real. The damage is real too. And the two aren't fighting each other, they're stacked directly on top of one another. Now go back to that small pond in the park. That same family is still standing there, still tossing pieces of bread onto the water, still smiling. But now you're watching the fastest duckling paddling toward the bread, and you know exactly what's quietly happening inside its soft wing joint right now, while nobody on the shore has any idea. The scene still looks just as warm as it did before. Only the way you're seeing it has changed. So the real question here was never whether you've ever fed bread to a duck. The real question is this: somewhere in your own life, is there something you're giving generously, at a pace and a dose you've never stopped to ask whether the structure underneath it could actually keep up with?